Hi guys, welcome to our channel of Sciences and Mathematics. Today we are going to discuss in summary about the nomenclature of organic compounds. We are going to look at different aspects of course, naming these organic compounds in summary form. This entails the general formula, the numbering, the suffixes and the prefix that we're going to use in this case. And then we are going to look at how we can be able to treat different substituents that appear in these organic compounds in summary form. So without further ado, thank you and welcome. So as we have said, we are going to look at a summary of the organic nomenclature that we've discussed in some of our videos. So that one will entail looking at the general formula for different classes of organic compounds, their functional groups, their parent name, and then the suffixes and prefixes which are used. And then we shall look at numbering and some of the rules that we use in order to denote the appearance of different substituents that we may encounter in various organic molecules. So in that case, we shall start with the first one. That's the first class of organic compounds that we call alkenes. Alkenes, as we have said in some of our videos, these are saturated compounds, which means the carbon-hydrogen bonding which appears in their molecules is full, which means they cannot be able to, of course, attain, as we have said, referring to as having the maximum number of the hydrogen atoms, of course, for the possible number of the carbon atoms which are present. So that basically refers to the term saturation or saturated that we're going to encounter in this case for alkenes. So for that case, for cyclic alkenes, the numbering starts with the carbonyl carbon. The numbering starts with the term cyclo, whereas the substituents are arranged in alphabetical order. So trying to look at these specific rules which apply to alkenes, then if we have this kind of an example, then we can see, of course, that we have said the functional groups did not contain any, but the general formula for the carbon-hydrogen ratio is represented as such. So in any case, if n is a particular number, let's look at this example. We have got 1, 2, 3, 4, which are numbered in red. For this chain, we have got 6, 7, 8, 9. So if it's a 9 carbon member, then we shall have 9 times 2, which is 18 plus 2, 20. Let's try to see the number of hydrogen. Of course, atoms, this is 3 plus 3, 6, plus 2, 8, 9, 10, 11, 12, 13, 14. Of course, there's a carbon. There are 2 carbon atoms at this particular point, which of course will mean that this is a 14, 15, 16, 17. Just a moment. There's of course 2 carbon atoms which have been omitted from here. So we shall have H2. So that's correct now. So we shall have the number of hydrogen atoms as this is 3 plus 3, 6 plus 2, 8. 9 for this plus 2, 11, plus 3, that is 14, plus 2, that is 16, 17. There's another hydrogen atom at this particular point, of course. That's have been forgotten. So we have a H there. So for that case, that's the correct now form for that particular kind of a compound. So we shall have, this is 3 plus 3, 6, 7, 8, 9, 10, 11, 12, plus 3, 15, plus 2, 17, plus 3, that is 20. So this particular kind of a structure conforms to this general formula. And then the functional group, there's none. The parent name is the longest chain in this particular compound. So if we look at this stretch we have written with red 1, 2 up to 6, and then we take a different route that is 1, 2, 3, 4, 5, 6. So this 2 forms 2 of the longest, two routes for the longest chains. That is the first one and the second one. But in any case, we take route 1 or route 2, the same way the compound will just be the same in that we shall have a 6-member carbon group, and then number 2, the kind of substituents that we shall have at this carbon number 4 are the same. This is because at this carbon number 5 and 6 and 5 and 6 form a 2-member carbon group that we call ethane. So that's an ethyl group for that case. So we take root number 1 and number 2, still we are correct. So let's take root number 1, then we shall have 6 carbon member, which is known as hexane. And then we have substitutions at point number 2, carbon number 2 and number 4 respectively. So for number 2 we have a methyl group, and number 4 we have an ethyl group. So in that case, if we try to look, we have identified the longest chain. The suffix, the name of this compound will end with the suffix N, representing alkanes. And numbering starts at the end near a branched point. So if this branched point, which is for the methyl, is at number 2, compared to if we counted from this point to carbon number 1, 2, 3, at this point, this one will be number 3. So basically this refers to the aspect of the numbering starting at this point near a branch of the methyl group. So this is a substitution at point number 2 and number 4. So in naming this, we use a specific format that we said that it starts with the numbering, which is of the substituents, which is of course number 2 and 4, number 3, and then the substituents are named in alphabetical order. This is a methyl group and this is an ethyl group. So E comes before M. So we shall have to identify the first substituent at carbon number 4. So the name will start with 4-ethyl, this is an ethyl group, and then that dash. And then number 2, 2-methyl, this is a methyl group. So these ones have been arranged in alphabetical order. And then the parent name is an alkane by the name hexane, representing a 6-member ring. a 6-member chain. So we have this suffix N. So the single name will be 4-ethyl-2-methyl hexane. For cyclic groups, they will as well follow the same format, but as we said that cyclic alkanes, the name starts with the name cyclo. So that one precedes the parent name, but for the substituents, first we'll have to name them. So we shall have to see the substance takes priority according to the order, of course, of the alphabetical order, and then they are given their number, which is the lowest number possible, which means the combination of these two numbers have to be lowest possible. Now suppose this is a start numbering from a substitution that has got the first name starts with the first a first letter from the alphabet. We have a methyl and an ethyl, so definitely we shall start with an ethyl as we have done with the first case. This is the number which we shall start with. So this is 1, 2, 3. So suppose we can decide to name it using this route, but we said the numbers should have the lowest combination possible. So we go in this route, which is anti-clockwise. Then we shall have ethyl at carbon number 1, 2, 3. So the combination is 1, 2, 3. So 1-ethyl, 3-methyl. Then because it's a cyclic, then we shall have cyclo. It's a 6-member carbon single bond ring, hexane. The suffix is N. So this is how we name this specific compounds that we call alkanes, or just the hydrocarbons that we call alkanes. Now for alkenes and alkynes, alkenes are the double bonded compounds that we carbon-carbon atoms that we have talked about, and then for alkynes, they are the triple bond that appears between the carbon-carbon bond. So specifically, their general formula appears as just like this: CnH2n. That is for alkenes, and then for alkynes, it is Cn2n-2. So the functional groups, this one represents alkynes and this one alkenes for the triple and double bond respectively. The parent name is the longest carbon chain with either the triple or single bond, and then the suffix is "-ine" for alkynes and "-ine" for alkenes, and then they can be followed by the di, tri, etc, denoting appearance of 2 double bonds, 3 double bonds, etc. And then the numbering ends with a multiple, and the number ends closer to the multiple bonds. Numbering, so we as well as we chose the end or the numbering to start at the end near the branched point. This is also the case for this, but we choose the end closer to the multiple bond. Now for cyclic alkenes or alkynes, the name begins as well with the term cyclo, and that's one we're going to see at by giving these specific examples. Now in that case, there are also some aspects which are going to appear of course, of some rules which are going to be characteristic for these two members of the organic compounds. Let's look at this first one. So we shall have, and in this case, when we are doing with these two names or three names, I want us to look, there's also an additional condition that is going to appear in this case, because as you see for this one was an alkane, but the appearance of double and triple bonds is going to give a specific characteristics for these two member compounds of the hydrocarbons. And let's look at this first example. This is a line structure. So we have carbon at this point 1, 2, 3, 4. So these are 4 member carbon, and this is a 1, 2, 3, 4, 5. We said that at each junction that we have the ending, or at the junction of these lines, we have a carbon atom. And then at the ends, we also have carbon atoms. So in this case, for this 4 member, this is from the parent alkane series, it's butane, but since it has got a double bond, it's going to be a butene. So we see that the numbering begins from the end closer to the multiple bond. So in this case, if we look at this compound, there's a double bond at the end, either from the right or left, so we can start naming it from another point. Either this is from this point or this one. So we can start by naming, this is 1, 2, 3, 4, butane. So in this case, the name starts with the but, but there's an A that is included at this point. This is in order to avoid the repetition of this particular vowel, that is, or the consonant T, D. So in that case, A has been included intentionally in order to avoid repetition of either the vowels or consonants to appear in that order following one another. So the name for this will be buta-1. This is the designation for the double bond. It's appearing at carbon number 1 and 3. So it is buta-1, 3-diene. And the same case applies to the second member, which is a butane. I mean, this is a bentane, because a bentane and as well as a bentene, because it consists of a triple and double bond. In case this, of course, appears like this, there's a preference for either the double or the triple bond, but both of them have the same or equal preference. So we can start from any point, of course, which is, as we have said, that closer to the multiple bond. Both of them have the degree of, the starting point, which is the same. So then we shall have 1, 2, 3, 4, 5. Now this one is not having inclination or maybe a bending like the other ones because of the rigidity of this kind of bond. So we shall talk about that one. So we have carbons 5, so that's a bent. So as we said that there is a particular order whereby if they appear two double bonds, we designate them with the term di, tri, etc. In this case, we've got what we call a bent. Suppose we were to write benta, then we shall have a vowel here and a vowel there. So to avoid that one, there's an elimination of an E, so that we have TE. So it is bent 1 in to designate the presence of the carbon-carbon double bond, and then dash 4, this one, ein, indicating that there's a triple bond at this point. So the name of this compound will be bent 1 in 4 ein. For cyclic groups, we said that for cyclic groups, the name begins with cyclo. So this one is how many membering? 6 membering, but we shall designate the location of this double bond by giving them the lowest number possible. So the counting will go anti-clockwise. We have 1, 2, 3. So we have a cyclohex. This is an alkene, so hex. So to avoid a repetition of a consonant, so we have hexa. just like the first case that we were talking about here. So we have hexa 1, 3, di indicating the appearance, twice the appearance of the double bond diene. So the name of this compound is cyclohexa 1, 3 diene. So suppose we have different substitution of maybe an aliphatic compound or the one that is not cyclic. How do we name that one? So let's look at this particular example. And this one also follows the same rules, only that when we have two different substitution for the carbon, then we shall use the alphabetical order to denote the different substituents. So for that case, we have that kind of a compound. And the numbering, as we said, starts from the point, the end closer to the multiple bonds. And this is the first one. So we shall number them starting from here. This is 1, 2, 3, 4. Suppose we follow this route, then we shall have 1, 2, 3, 4. But we will have omitted this substituent that is for fluorine. So we shall have a straight kind of a chain, which will also give us the 4, which is from the parent alkane series, that is butane. But since it has got a triple bond, then it will be butane for alkynes. So let's try to see that the designation for the substituents and which order do they appear in form of alphabetical order. So we have a methyl group here, and then we have 2 fluoride groups which have substituted here. So we call them fluoro. So we have 4,4-difluoro because there are 2, 3 methyl, carbon number 3, but 1, so the triple bond is appearing at carbon number 1, but 1 ine. So the name of this compound will be 4,4-difluoro 3 methyl but 1 ine. So as we have said that this case for the numbering of the first and the second compounds, the ones I've written in blue gives the condition for trying to include that particular letter A and B, as we said that an A is added with the inclusion of di, tri. Those are the prefixes that denotes multiplication of maybe appearance of double bonds for 1 or 2, in order to ensure that the consonants do not follow one another consecutively. And also for the E is eliminated in this second case for this compound to ensure that the vowels do not follow one another consecutively, but ensuring that this suffix is maintained. So for that case, if it were to be written the other way that we have discussed, which is not the case, it could appear like this, but the E has been eliminated. So that's for the naming of this class of organic compounds that we call alkenes and alkynes. Next, we shall look at the naming of alcohols. Now, the functional group for alcohols is a radical, which is joined to a OH group, and then the parent names is formed by the longest carbon chain that is containing the OH group, which is a functional part of the functional group. And then the suffix alcohols names end with "ol", or in case maybe there are 2 OH groups that appear, then it will be a diol and triol for 3. Numbering will begin at the OH group, the carbon that is attached to the OH group. And then for cyclic compounds, the parent name begins with cyclo. Let's look at this compound here. Now the functional group, as we have said, is R attached to O. And then for that case, the numbering, of course, we shall start to count from, of course, the end near to the OH group. That is carbon number 1, 2, 3, 4, 5, 6. So for that case, from the parent alkane series, that one we shall have hexane. So since we have said that it ends with "ol", then that one will be hexanol, hexanol. But we have substituents at point number 1, 2, 3, 4. At point number 5, we have a methyl group, of course, which is appearing on this. So suppose we take this route and the other one, the straight one and the other one, we will still find the same number of 6 carbon atoms, and the substance will be the same. So either routes are correct, so we shall use the straight one. So we shall have 5 methyl, this since it's the only substituent, and 3 hexanol, implying that the all OH group is attached at carbon number 3. So suppose it's a cyclic compound, then the rules also shall apply for the alphabetical order of substituents. and then the designation of the term di or tri if the OH groups are appearing twice or more than once. So for this case, the numbering will be given depending on the position of the OH group. Then we shall have to count from this to give the substituent the lowest number possible. So we shall have, this is 1, 2, 3, 4. So OH appeared number 1, 4 respectively. But for this case, we have also said that if it's an there's a double bond, then the numbering end begins at the end closer to the multiple bonds. This is for molecules that have alkenes and alkynes. So we shall as well choose the other roots because it's going to give us a combination of 1, 4 for the main functional group. So this is the root that is recommended against the other one that we were doing at first. So we shall have 1, 2, 3, 4 OH groups appearing at number 1 and 4. This is a okay, 1, 2, this is 1, 2, 3, 4, 5. Just a minute. 1, 2, 3, 4. Just a minute, there's something that I would like. So basically be named as 6-methyl cyclohex 2-in-1,4-diol. So as we said about the consonant or vowel following one another here, there's also that rule that we have discussed which are applicable for alkanes and alkenes, which has been applied in this particular case. So then we shall have the carboxylic acids whose functional groups consist of R attached to a carbonyl carbon, and then we have a proton at this particular point. So remember there's a difference between this this is a COO negative H plus, which forms the acid, that of these carboxylic acids. So the parent group the parent name comes from the longest carbon chain with the functional group, that is RCOOH, and then the suffix ends with oic acid and dioic in case there are two. The numbering starts at the carbonyl carbon. This is the one that is referred to. For instance, if we have this for circular and then we have for phenyl and then we have a chain one, the functional group is at this particular point. So the numbering will start at this 1, 2. There's substitution at carbon number 2. So we have, that is for chloro or chlorine. For chloro, the substituent will be referred to as chloro. So we have 2 chloro. It's a 3-member carbon. So that's from a propane, which is alkane series propane. So for this case, we shall have 2 chloropropane, and then we add the suffix oic acid. So it is 2 chloropropanoic acid. And then for this, there's an amine group, the phenyl group that has been attached at point number 2 and 3 respectively. So we shall start using the alphabetical order. We have amine A starting and then P for phenyl. So we have 2 amino, 3 phenyl, 1, 2, 3 phenyl propanoic acid. Lastly, we shall look at the esters. Esters, we said in one of our videos that it's a product that is formed by the reaction of carboxylic acids together with alcohols. So we have a functional group for esters. Of course, this is for it's a correction that we need to form here. This is a functional group for esters. This is a radical at this particular point and not a OH. So we have, perhaps we shall have a radical which is noted by R and then R prime. They can be the same or different. So for that case, we just use for R and R prime. So this is a functional group for carboxylic, for esters. The parent is an alkyne name of the carboxylate anion, of course, which we have indicated here using that general formula. So we have alkanoate, which consists of the COO negative from part of the carboxylic acids, and then we have a radical, that's an alkyl group. So the name goes in that format of alkyl alkanoate, and the suffix ends with -ate. The numbering begins at the carbonyl carbon. So suppose we have this example whereby it has got this particular point, which is the alkyl group, and then from this O ending this way towards the left, we have at this particular point and junction of this OH or OC, this section forms what we call an alkanoate, and that's an alkyl group. So this is an ethyl group which consists of 2 carbons. So we start from this name, which is an alkyl. So it is an ethyl. 1, 2, 3, 4. 4-member carbon is butane. So from the alkane series, so we shall have ethyl butanoate. So this is from the alkanoate that we talked about, and the suffix ends with ate. So we shall have that name as ethyl butanoate. So guys, we come to the first section of a summary of the nomenclature of these organic compounds. We shall have a second one, which of course we shall consist of the last cohort of these compounds, which we shall discuss. Of course, this summary is going to assist us to use as a reference in case we need to name some compounds that we have discussed in some of our videos. So that is it for today. Thank you and welcome. God bless you. Bye.